This is a short video tutorial for a teacher to perform an experiment for their grade 5 science class. The overall expectation in the curriculum we're trying to meet is?
So we're doing number 2, investigate the structure and function of the major organs of various human body systems. So we're looking at the organ, the heart, and specifically the circulatory system of the heart.
The hypothesis. The hypothesis for this experiment is the more constricted or smaller diameter of the blood vessel, the slower the blood will flow. Obviously we're not using blood, we're using water. The other props to perform this simple experiment we have here is a large diameter funnel. Ours measures approximately 18 millimeters at the bottom opening. A smaller funnel that's about half the size. So this one is a 9 millimeter diameter opening at the bottom. A bowl to collect the liquid in, a measuring cup clearly labeled for the grade 5 class at 500 milliliters so that they can measure out the liquid. Obviously a sheet to record the time it takes the liquid to pour through the various funnels, and the water. So I will fill the container up with the water to the 500 milliliters. However, we're going to use we're going to talk about the specific expectations of this experiment before we go on with it.
So we're going to be looking at the specific expectations number 2.2, which is use scientific inquiry experimentation skills to investigate changes in body systems. So again, like I said, we're investigating the circulatory system today, and specifically how changing the diameter, either constricting or dilating the blood vessels, changes the flow of blood to either increase or decrease the rate that the blood is going to flow through the circulatory system. We're also going to be doing specific expectation number 2.4, which is use appropriate science and technological vocabulary, including circulation and organs in oral and written communication. So we're going to be looking at circulatory system of the heart, how the heart pumps blood throughout the body, supplying O2 and nutrients to all the organs throughout the circulatory system.
The teacher can then refer to the appropriate sections in the academic book to point out, what the heart looks like and how the heart functions pumping the blood through the actual blood vessels. Then we have our representation of the blood vessels. So once again, the students will have their timer ready. So they'll be in groups of 2. They will take the larger funnel. There are 500 milliliters of water that's measured out, and the timer starts as the water goes through the funnel. And stop. This gets recorded as the amount of time that it took the 500 milliliters of water to go through the large funnel. Then the students will recollect the water and perform the exact same procedure using the small funnel, which now represents a constricted blood vessel. Did you want to show the diagram?
I don't think I have one for that one, actually.
So we'll start the timer again.
Okay.
Using the funnels at various diameters is good, but keeping them definitely half the size. Stop. Has the students see a very different length of time, and then that gets recorded. So once this is done, the teacher can then go on to expectation 3.4, which is?
Identify common diseases in the organs and or body systems that they affect. So I have a diagram for this one. We're looking at arteriosclerosis. So that's a buildup of plaque in the circulatory system, and therefore if you have a buildup of plaque inside the blood vessel, it's going to slow the rate of blood flow that can go through the blood vessel at a point in time just because it's constricted.
And that was represented by the smaller funnel in this case in the experiment. Then we'll move on to our second experiment. In this one, we will not be using the small funnel. We will be having water again, and also a thicker viscosity liquid corn syrup, because the overall expectation in this one is also?
It's the same number 2, investigate the structure and function of the major organs of various human body systems. So we're looking at the heart again, specifically the circulatory system. and we are looking at how the viscosity or the thickness of blood is going to affect the rate of flow through the blood vessels.
So again, as I said, we'll use a large funnel to represent the normal blood vessel, a bowl to collect our marked out 500 milliliter container, our recording sheet down here where we have water versus corn syrup and the time that it elapses. So a two-student experiment again with a timer. We will fill the 500 milliliter container, and just as in the first experiment, we will start the timer. And stop. That gets recorded in for the water segment. Now for our corn syrup. Again, we'll need to measure this out. The students will have fun with this. Other viscose materials can also be used. We can have
That's good enough.
I think so.
They'd have the correct amount.
Again, I wouldn't recommend using honey, that would be too sticky, but you can make a corn syrup mixture as well. Then the student will simply take the timer and measure the time it takes for this corn syrup or other suitable viscous material. Perhaps even cooking oil. And this is going to take some time. So we'll stop the experiment now because it's only a demonstration.
No, don't stop the video.
No.
So then the student would then mark down the time it took for the corn syrup to go through.
So the specific expectations are the same as in the first part of the experiment. We are doing 2.2, use scientific inquiry experimentation skills to investigate changes in body systems. So we looked at the circulatory system and specifically how the thickness of blood will determine the rate of flow through the circulatory system. We also did 2.4, which is use appropriate science and technological vocabulary, including circulation in organs in oral and written communication. So this is how the circulatory system of the heart, how the heart pumps blood throughout the body, supplying O2 nutrients to all other organs depending on the thickness of the blood. That will determine how fast the blood is going to flow through the circulatory system. And then our last one, 3.4, identifying common diseases in the organs and or body systems that they affect. So something that can affect the viscosity of the blood is a condition called polycythemia, which is an abnormal increase in the amount of red blood cells. So the more red blood cells that a person has above the normal limit is going to increase the thickness of the blood and do similar effects to the blood vessels as we saw in the experiment.